Very good morning.
Good morning, sir.
Good morning, sir.
Okay, for today's class, we will request 4 to 5 people to join with us from Ajay. Ajay, Ajay, not yet joined. Okay, have you solved the last problem? What was the answer for the last problem? What is the U1, U2, U4, and U5?
So U1 and U5 will be same. I'm getting it around 180, U2 around 185 and U4 around 235.
Sapnipal, any other answers other than Sapnipal?
Sir, I'm getting U1, U3, U7, and U9 equal to 188, and U5 as 201, and U4 as 251, and U6 as 251.
Right, but the thing is, instead U2 U8 you said the U5, that is U5, that is U2 and U8 are same 201, and what is your U4 and U6?
So
What is your
251.
very good, very good. Then what is U5?
Sir, I must have calculated it wrong, sir. I'll calculate again.
Okay, good. Okay, good. Okay, we'll start today's session, and around 29 people joined. So far, what we have seen, we have started Unit 4 and solving boundary value problems and whether it may be ordinary or partial differential equation. Um, and in that we have with the basic information, that is with the aid of quadratic equation, with the solution of b square minus 4ac, we can find whether the given solution belongs to elliptic or parabolic or hyperbolic. We have started solving the problem under elliptic. In elliptic itself, we have two different classification. One is Laplace, the other one is Poisson equation. We have started solving Laplace equation, and for our today's class, we will request some people to join with us. Ajay, 42, 45, 57, 60, 63. Please join with us. From 42 to 63, please join with us. 42, Ajay, Campbell Komal, Kumar Raja, Maharajan, Marikanti Ashwin. These five, you please unmute your mic till the session. Please join with us. When there is a query with the answer, please respond. Please have your calculator with you. Please have your calculator. And this is what we have introduced the eigenvalue problem and boundary value problem. And if the format, that is dou square u by dou x square plus dou square u by dou y square is equal to 0, then that is elliptic, that is called Laplace equation. The other one is Poisson. If we have the RHS, then that is Poisson equation. In exercise number 1, we have identified the problem belongs to elliptic, parabolic or hyperbolic, that we have identified. And this is the standard 5-point formula. And see here, uij is equal to 1/4 of various boundaries. This 4 has to come here, and when this 4 multiplies with the ui comma j, then here also we have the mesh size. If the mesh size in the x-axis belongs to h, and the mesh size in the y-axis is termed as k, and in Laplace equation we have considered the uh, mesh size of x-axis, that is h and k, is equal to 1. Here see, here the mesh size, the difference between these two vertical lines, or the difference between two horizontal lines, that is said to be in mesh size. And this difference in x-axis is said to be in h, and the difference in y-axis is said to be in k. And here we have considered the difference in x and y as 1, that is k, h and k is equal to 1. That we will discuss in detail little later. And we have started our problem, and this is Liban's iteration formula. When there is an updation in u value, that has to be considered for subsequent in the present iteration itself. We need to consider the newer iterations value, what we did in Gauss-Seidel. And this is the first problem we have solved in um, Laplace equation, various boundaries, and we have solved various iterations. And this is the solution. In the question they are requested us to get the results with 1 decimal places. Therefore, we have stopped our iteration with 1 decimal places, that we can achieve through the second iteration itself. Sorry, in the third iteration. And this is the solution. And similarly, we have solved the exercise number 3. And I have requested you to solve this problem. And this is your solution. This is your solution. That is your u1 is equal to here there is a similarity. That is we are going to find u1, u2, u4 and u5 alone. Others are symmetric. u1, u2, u4 and u5. u1, u2, u5. Not to calculate the other values, write it on the table. Then it is easy to calculate.
Sir?
Yes. Any queries?
Sir, yeah. Sir, if we apply diagonal rule on that u5, then it will be 1/4 of u1 plus u3 plus u7 plus u9. Since u1 equals to u3, u7 and u9, so why won't u5 be equal to u1?
Pardon. Once again.
Sir, u5 is, if we apply diagonal formula, u5 is 1/4 of u1, u3, u7 and u9 addition, right?
Yes. Then the 4 u1, 4 will cancel. Then we can consider u5 is equal to u1. That is your view. Is it right?
Yes, so that's my view.
But for our initial iteration, what we have to consider, assume the initial iteration. As I already compared the standard 5-point formula and diagonal 5-point formula. When there is no way to apply the standard 5-point formula, at that time only you need to refer diagonal 5-point formula. Because the yielding ability of standard 5-point formula is greater than the yielding ability of diagonal 5-point formula. When there is no way to apply standard diagonal 5-point formula, at that time only we need to refer diagonal 5-point formula.
Oh, okay, sir.
Therefore, it is, for finding u5, the diagonal 5-point formula is not suggested. When we have 4 boundaries in horizontal and vertical, then why you are referring diagonal 5-point formula? That is not suggested. That is not suggested. And therefore, in order to get the better results, the standard 5-point formula is applicable. Therefore, apply the standard 5-point formula. Therefore, we need to get various U2, U4 values in order to find U. Very clear then? Okay. I think this is the result of the last problem. U1 is equal to U188 and U2.
So can you show the last slide once again?
Yes. This slide or this is one? You are seeking this one?
No, sir. The one you were showing right now. Not this. Not this. Yes, sir. This one.
Yes.
Thank you, sir.
Okay, good. We have consider the entire solution. The diagonal 5-point formula is applied in order to find U1, U3, U5 and U7 in the 0th iteration alone. See the previous problems in exercise number. This is the first problem where we have applied this diagonal 5-point formula. Not
It is audible. Hey, gentlemen, it is audible.
Sir, it's audible, but the voice is breaking.
Right. Now check with the audio.
A lot of background noise is there. We can't hear you properly.
Wait, little louder.
It's fine now. It's fine now.
Okay, good. Okay, we'll power drop. I cannot continue the presentation with my laptop. Therefore, we will continue the session with our mobile phone. And see, in exercise number 3, we have applied the standard diagonal 5-point formula for finding the results of U1, U3, and U7 and U9 alone. And for the rest of till the end, we didn't apply the diagonal 5-point formula. Therefore, Therefore, it is suggested to apply the standard 5-point formula. When there is no way to apply standard diagonal 5-point formula, then we need to depend the diagonal 5-point formula. I think I have answered for your question, Bhavya, or who asked the question?
Yes, it's clear now. I answered.
Okay. And concerning the exercise from which we have given for you is U1, U3, U7, U9 is equal to 188, and your U2 and U8 is equal to 201, and your U4 and U6 is equal to 251, and your U5 is equal to 226. And please make a note of I will share my notes. Please make a note. Yes. This is your problem number. I think five. Solve uxx plus uyy is equal 0 for the following square mesh with boundary values shown in figure. Iterate until the maximum difference between the successive values at any point is less than 0.001. Yes. Now check with the audio.
So the audio is clear, but
Yes,
I
sir.
think the orientation of the camera is like it's vertical for us.
Oh, have you noted down the problem? Again, shall I share? Or if you have noted down, please start solving the problem. Shall I share one more time? This is Anand Modi.
Yes, sir. Once, please.
Okay. Yes. Solve uxx plus uyy is equal to 0 for the following square mesh with boundary values shown in figure. Iterate until the maximum difference between the successive values at any point is less than 0.001. And see the diagonal, usually the diagonal values are given in the problem itself. For this particular case, there is no value given for the diagonal, and here A at the left topmost corner and C in the right bottommost corner, and B on the right topmost and D in left bottommost. And concerning the AC C with the main diagonal AC, there are the other boundaries. We'll get 2 2 3 3 3 3 again 2 2 in the boundaries, and similarly concerning the diagonal BD, and we are getting the same boundaries. Some boundaries are symmetric. Therefore, here the given problem is symmetric about both diagonal. Instead, U1, U2, U3, U4, initially you give the value which we have practiced so far. Initially, you apply U1, U2, U3, and U4. Then convert your all known into one. That is, here U1 is equal to U4 is equal to U1. Therefore, instead U4 we are going to take U1, and instead U3 are similar to U2. Then it is enough to find with U2. Therefore, instead of finding 4 different values, it is enough to solve the problem with only 2 values, that is U1 U2. U1 is equal to U4 and U2 is equal to U3. You please solve the problem and tell me the answer. Have you noted down the problem? Please anyone. Please anyone. Yes. For your first iteration, what is your result? You are going to solve the problem. Tell me the results. Tell me the results. What is your U1? Initially assume U2 is equal to 0. And what is your result? What is your U1? 0th iteration, what is your U1 and U2 value? Is Ajay, Campbell Komal, Kumar Raja, Maharajan, Marikanti Ashwini. Please unmute your mic and please respond us. Yes. Yes, U1, as Bhavya replied, U1 is equal to 1. What is our U2? No, not 1.5, Bhavya. 0.25 instead, and how we have solved the last problem. In the calculator, you give 0.25 into A plus B plus C plus D. Give CALC, that will enquire about ABCD. Here, in order to calculate U2, we need to apply U1 as 0. 2, yes, of course, 2. And others, please respond. Ajay, Campbell, Komal, Kumar Raja, Maharajan, Marikanti Ashwini, please unmute your mic. Please give the.
Yes, I even got 2.
Yes, please unmute.
Yes.
Okay. Okay. Your 0th iteration is good. Now, please concern about your first iteration. What is your U1 and U2?
So I have another doubt. So why are we considering U2 to be 0 if we can substitute the values of U1 and U2 and then get U1?
In the 0th iteration itself, we are seeking.
So it wasn't given in the question that we're supposed to consider U2 to be 0. So like u1 is 1 plus u2 by 2 and u2 is 1.5 plus u1 by 2. So sir, why can't we use substitution over here and then find u1 and u2?
And in order to get the results, you have two different equations and two different results. You have your two equations and results of that particular two equations.
So two equations, two variables we can solve, no sir?
Yes, then solve and find the result.
Yes sir, but the answers are coming different.
Okay, I'll check with the results and I will tell you.
Yes.
Okay, go ahead with the earlier procedure. What is your first iteration?
So like my procedure or your procedure, sir?
Our procedure.
So your class procedure U1 is 1 and U2 is 2.
2. Okay, do with the first iteration.
Yes.
Continue the iteration. Okay, good. 2.5 is right. For first iteration, 2 to 2.5 is right. For second iteration, what is the second iteration? U1 and U2.
So 2.25 and 2.625.
Yes. 2.25 and 2.625. Yes. Continue your iteration.
So 2.3125 and 2.65625.
Very good. And the stopping criteria is in the problem itself they have given that the success value at any point is less than 0.001. Therefore, we need to continue our iteration. The difference in the success values should be 0.001. ஆமா. இதை வச்சு உட்காந்துங்க அப்படியே உட்காந்துங்க. And concerning to your fourth iteration, anyone got the results?
So 2.328125 and U2 is 2.6640625.
Very good. And your fifth iteration?
2.3320 and
Yes.
U2 is 2.66601.
Very good. And our successive iteration difference is less than 0.001? No. 328, 2.328 and 2.332. There is no difference is equivalent to 0.001. Therefore, we need to continue our iteration. The sixth iteration.
Sir, 2.3330 and 2.6665.
Very good, very good. And concerning your iteration number 7.
Sir, I'm doing.
And concerning your iteration 7, you will get 2.3333 and u2 2.6666. Therefore, the successive iteration values becomes 0.001. Therefore, we can stop our iteration with seventh iteration, and I will steam the results as said by Sabranipal. And this is your results. This is your second iteration and third iteration, fourth iteration, and this is your second iteration. This is your third iteration. This is your fourth iteration, and this is your fifth iteration. This is your sixth iteration, and this is your seventh iteration. So please make a note, and please make a note. We'll take the attendance, and then we'll continue our class. And I think all are present. Please, representative Anand Modi, Bhavya, Rahul, and Sabranipal. Please check with the participant count.
Yes, sir.
Is 36, isn't it? Please Anand Modi and Sabranipal, please check with your class, and Rahul and Bhavya, please check your class. And I think all are present. Four are absent. I think Anand Roshan, Aravind Roshan, Rahul Arya, Sai Ganesh, and Vikash Mavi. Am I right? Aravind Roshan, 88 Rahul, 88 Rahul.
Yes, sir. That's it.
Sai Ganesh.
Yes, sir.
And
From only Vikas, sir.
okay, only 4 absent today. Okay, good, fine. Okay, we'll continue with the class. Okay, as enquired by Sabrina or Bhavya, how we will solve U1 U2? Please.
Sir, see, sir, u1 equals to 1 plus u2 by 2 and u2 equals to 1.5 plus u1 by 2. So, sir,
wait, just a minute. U1 is equal to
1 plus
0.25 4 plus 2u2. Okay, 1 plus 0.5 u2. Okay.
Yes, sir.
Okay.
And u2 equals to 1.5 plus 0.5 u1.
1.5 plus 0.5 u1. Okay.
Yes, sir.
By solving this two equation, what is your result?
Sir, by solving these two equations, sir, u1 is coming out to be 2.333 and u2 is coming out to be 2.666.
Yes, what we are achieving in the last solution, we are getting in the first iteration itself, isn't it?
Yes, sir.
Okay. Tell me, I'll check with the various sources and I'll tell you. why this larger difference occurs, and what was the drawback in adopting in a direct way by solving two linear equation. Why can't we apply in this way to get the results? That I will check with the textbooks, and even I'll consult with the process and tell you.
Yes, sir. Thank you.
Okay. Uh, and this is for your practice, and as similar to the earlier problem, in this problem also, please make a note. Please draw the diagram. And this problem is symmetric about not both the diagonal. It is symmetric about the main diagonal alone. And 1, 1, 2, 2. Similarly, we don't have the corner points. We don't have the corner points. And this is the problem. Using Liebman method, solve the equation dou square u by dou x square plus dou square u by dou y square is equal to 0 for the following square mesh with the boundary values as shown in figure. Iterate until the maximum difference between the successive values at any point is less than 0.001. And here are it is symmetric about x axis. Make it as an axis xx. If there is a no representation over the diagonals, you yourself make it give an address for that particular zone, and here it may be A and B or CD or PQ or XX. We'll take it as XX. It is symmetric about XX axis. Therefore, your U2 is equal to U3. Therefore, we need to find the three different values: U1, U2, and U4. We need to find U1, U2, and U4. And your result is by solving this particular problem, you will get. This is your zeroth iteration. In zeroth iteration, you will get 0.5, and in your zeroth iteration, your U2 is equal to U2 is equal to 2.25, and your U4 is equal to 2.5. Similarly, by doing successive iteration, you will get these are first iteration results: U1, U2, and U4, and this is the results. And U1, U2, U2 and U3 and U4. And U1 might be 2, and U3 might be 3, and our U4 might be 4. And okay, shall we continue? Rahul?
Yes, sir. Yes.
Okay, good.
Yeah,
And
10 more minutes, sir. You can continue.
yes. This is the Poisson equation. In the elliptic, so far we have seen the RHS is equal to 0. But in some cases, the RHS, we have some values for RHS. Dou square u by dou x square plus dou square u by dou y square is equal to f of xy. Then this is a partial differential equation, which is called as Poisson's equation. And we can find the x and y with the aid of the formula which we have already seen. Here, see, this is the formula we are going to take for finding the results. U I minus 1 comma j minus 2 u I comma j plus u I plus 1 comma j divided by h square. This is the term which is related to x-axis, and similarly y-axis, and u I comma j minus 1 minus u I comma j plus u I comma j plus 1 divided by h square. Instead k, here also we have given h, because we are going to take the similar mesh in both axes. H is equal to k, and here x is equal to ih into y is equal to ij. We are taking for our concern for finding the results. Instead, xy we are going to take as ih comma ij comma jh. And by simplifying this particular, how we are achieving this one, that I discussed during the derivation portion. And this is what we have applied in Laplace also. In RHS we have 0 in Laplace. Therefore, here h square and h square become on RHS by multiplying with 0, that will become 0. And here minus 2i minus 2 uij. Here also we have minus 2ij uij. This both will come on the RHS. 4. Therefore, we will get 4 uij. That 4 comes this side for the division, that is 1/4 of various 4 boundaries that we have got in Laplace equation. As similar to that of Laplace, here we have base h square. Here instead k square we have h square. On RHS we have term. When we have RHM, this we have to keep the h square and k square as it was. And by rearranging this equation, what we'll get by multiplying h square on RHS, this h square goes on to the RHS. Here u I minus 1 comma j, u I plus 1 comma j, u I comma j minus 1, u I comma j plus 1 minus 4 uij. Minus 4 uij is equal to h square f ih comma jh. And in order to verify the equation whether it belongs to elliptic, and here a is equal to 1, your b is equal to 0, your c is equal to 1 in the given equation. The term which is associated with xx a, the term which is associated with yy is your c. The term which is associated with the xy, we doesn't have such a term. Therefore 0, by applying a and c value, we'll get minus 4. It is less than 0. Therefore this equation belongs to an elliptic equation. With the aid of this mathematical relation, we are going to solve the problem. And this is the problem which we will solve in Poisson equation. Please make a note. Solve the Poisson equation. Del square u is equal to, if del square is equal to 0, that is Laplace. If del square u is equal to some value, whether it may be 8x square y square or some other values, if it has some value, it is not equal to 0, then that is called as Poisson equation. And if del square u is equal to 8 x square y square for the square mesh of the given figure with u xy is equal to 0, that is the boundary. For various x and y, the u value is equal to 0. Here all the boundary values are equal to 0 on the boundary, and the mesh length is equal to 1. and please make a note. It is a simple 9 mesh problem which has a boundaries 0, and we can dilute this problem by taking symmetry. This problem is symmetric about both axes. It is symmetric about both x and y axis. Therefore, here instead of finding various u, it is enough to find with only 3. That is u1 is equal to u3 is equal to u7 is equal to u9, and u2 is equal to u4 is equal to u6 is equal to u8, and u5 we can take it as u5, or it can be considered as u3. And our h is equal to 1, that is given the problem itself. Therefore, the formula becomes here. Please make a note of this particular formula, that is given h is equal to 1. For a standard 5-point formula, we will get by applying h value in the given equation, that is 8. Here the h square f ih comma ij. By applying the h value in the given RHS, 8 1 square ih whole square ij whole square, I square j square, and h is equal to 1. Therefore, we are getting the RHS as 8 I square and j square, the LHS as it was. This four terms we are having in Laplace. This will be on the right, but here in Poisson, this is along with the LHS. Minus 4 uij, we have the RHS term. And based on the 4 unknowns, that is u1, u2 and u5, u1, u2 and u5, we are going to find the results. This we will solve during day after tomorrow's class. And do you have any query with the Poisson equation? Have you noted down the problem? We'll solve this problem in the day after tomorrow class. And do you have any query with the Poisson equation, Poisson relation?
No, sir.
Okay. Have anyone planned for CT1? Anyone planned for CT1? Representatives?
Sir, some discussion is still going on. Like some of them have.
Okay, we'll plan one CT in this week.
So this week already we are having one HSIR CT, so.
Okay. Anyway, please have a discussion and tell me. Anyway, CT come all the CT you are attending in one particular week during your regular classes. Why you are worrying? And please stop recording, Anand Modi. Please stop recording.